Good day, learners! Are you ready to have fun with math? How do you feel today? I hope you are all okay. I am your teacher Anne, and let's make learning more fun. Before we start, here are some reminders to keep in mind. Number 1. Stay alert and focus to the video lesson. Number 2. Prepare your pen and paper for your answer sheets. Number 3. Sit back and relax as you enjoy our learning for today.
Good day, learners. Before we begin, find a comfortable place, have your pen and paper with you, and make sure you have your learner's material. Let us start. Our topic for today is operations and radical expressions. Before doing the adding and subtracting of radicals, we must compare first which are similar and dissimilar radicals. Similar radicals or like radicals are expressions with the same index and radicand, such as square root of 2 and 3 square root of 2, 2 square root of 3 and negative 5 square root of 3, 3 square root of x and negative 2 square root of x. While the similar radicals do not have the same index and radicands, such as square root of 5 and cube root of 5, cube root of 4x and cube root of 2x, square root of 2 and the square root of x. Now, you already learned about similar and dissimilar radicals. With that, you can only add or subtract radicals which are similar. Here are the steps required for adding and subtracting radical expressions. Step 1. Simplify each radical if needed. Step 2. Add or subtract the coefficients of the radicals having the same radicand and index. We will have some examples and apply these steps. Let us look at the first illustrative example. Add 2 square root of 3 plus 3 square root of 3. Step 1. Simplify each radical if needed. Since each radical is already in their simplest form, we will now proceed with step 2, which is adding or subtracting the coefficients of the radicals having the same radicand and index. Let's look at the radicals. They have the same radicand, which is 3, and same index, which is 2. Now, the other coefficients are 2 and 3. Then, we will affix their common radical. The answer will be 5 square root of 3. Kinda easier, right? Let's have another example. Subtract 9 square root of 5 minus 2 square root of 5 minus 4 square root of 3 minus square root of 3. For step 1, are the radicals in their simplest form? That's right. All the radicals are already in their simplest form, so we will now proceed with the second step. Add or subtract the coefficients of the radicals having the same radicand and index. Since 9 and negative 2 have the same radicand as well as negative 4 and negative 1, we can now combine the terms with similar radicals, such as the quantity of 9 minus 2 square root of 5 minus the quantity of 4 plus 1 square root of 3. The answer will be 7 square root of 5 minus 5 square root of 3. Did you have the same answer as shown? Good job! Another example, simplify the square root of 18 minus 2 square root of 27 plus 3 square root of 3. Step 1. Simplify each radical if needed. So, the square root of 18 is equal to the square root of 9 multiplied by 2. Next is the square root of 27, which is equal to the square root of 9 multiplied by 3. And just copy 3 square root of 3, because it is already in its simplest form. Then simplify. We will get 3 square root of 2 minus the quantity of 2 multiplied by 3 square root of 3 plus 3 square root of 3, which is also equal to 3 square root of 2 minus 6 square root of 3 plus 3 square root of 3. We will now proceed to step 2. So our radical expression now is 3 square root of 2 minus 6 square root of 3 plus 3 square root of 3. Add or subtract the coefficients of the radicals having the same radicand and index. Remember that we can only combine similar radicals. So So, 3 square root of 2 minus the quantity of 6 minus 3. Affixing the common radical, the final answer is 3 square root of 2 minus 3 square root of 3. Can you follow? I hope so. Last example for adding and subtracting radical expressions. Simplify 4 square root of x plus 6 square root of x minus 9 square root of x. For step 1, let's simplify each term. Since each radical is already in their simplest form, we will now proceed with step 2, which is adding or subtracting the coefficients of the radicals having the same radical index. Then, we will have the quantity of 4 plus 6 minus 9 affixing their common radicals. The final answer now is square root of x. Let's now proceed to multiplication of radicals with the same index. To multiply radicals, apply the laws of radicals, which states nth root of a multiplied by nth root of b is equal to nth root of b. Let's have an example to further analyze it. For the first example, we have a square root of 3 multiplied by a square root of 5. Since we have the same index, we will just multiply the radicals. So we will have square root of 3 multiplied by square root of 5. And that is square root of 3 multiplied by 5. And then simplify, we will get the square root of 15, which is also our final answer. As simple as that. Easy, right? Let's have another example. We have 4 cube root of 3 multiplied by 2 cube root of 2. Since we have the same index, we will multiply the radicals, and then the two coefficients will also multiply. So we will have 4 multiplied by 2 cube root of 3 times 2. Then perform the operation. We will have 8 cube root of 6, which is also our final answer. Let's have the last example for the multiplication of radicals with the same index. We have square root of 6b cubed multiplied by 4y squared, or multiplied by the square root of 4y squared. So, we will multiply the radicand since we have the same index. So, we will have the square root of 6 multiplied by 4 multiplied by b cubed multiplied by y squared. We separate the terms because we have two coefficients, which are the numerical coefficient and the literal coefficient. And then we will separate it by term. So we will have the square root of 6 multiplied by square root of 4 multiplied by b squared multiplied by b, which is also equal to b cubed multiplied by square root of y squared. And then simplify. We will have 2by square root of 6b, which is also our final answer. Let us have multiplication of binomials with radicals having the same index. In general, multiplying radical expressions with more than one term follows the rule for multiplying polynomials where the distributive property is applied. Always express the product in its simplest form. For the first example, we have 2 square root of 2 multiplied by the quantity of 4 square root of 2 minus square root of 3. In this case, we will apply the distributive property. So we will have the quantity of 2 square root of 2 multiplied by 4 square root of 2 for the first, minus the quantity of 2 square root of 2 multiplied by the quantity or multiplied by the square root of 3 for the second one. And then perform the operation, we will have the quantity of 2 multiplied by 4 square root of 2 multiplied by 2 minus the quantity of 2 square root of 2 multiplied by 3. Simplify, we will get 8 square root of 4 minus 2 square root of 6, which is also equal to 8 multiplied by 2 minus 2 square root of 6. And the final answer is 16 minus 2 square root of 6. To multiply radical expressions with two terms, use the FOL method as input in multiplying polynomials. Let's have the second example. The quantity of the square root of 2 plus the square root of 3 multiplied by the quantity of 4 square root of 2 minus 2 square root of 3. we are going to apply the fourth method. So we will have for the first term, the square root of 2 multiplied by the quantity of 4, the square root of 2, minus the square root of 2 multiplied by 2, the square root of 3, plus the square root of 3 multiplied by 4, the square root of 2, minus the square root of 3 multiplied by 2, the square root of 3. Perform the operation, we will get 4 the square root of 4 minus 2 the square root of 6 plus 4 the square root of 6 minus 2 the square root of 9. Then simplify, we will have 4 multiplied by 2 minus 2 the square root of 6 plus 4 the square root of 6 minus 2 multiplied by 3, which is also equal to 8 plus 2 is square root of 6 minus 6. And the final answer is 2 plus 2 is square root of 6. Are you ready to proceed with the next one? Let's go. Let us have division of radicals with the same index. To divide radical expressions, apply the laws of radicals, which states nth root of a divided by nth root of b is equal to nth root of a divided by b, which in b is not equal to 0. Let's have an example. For the first example, we have the square root of 63 divided by the square root of 7. As the law states, combine the radicals if they have the same index. So we will have the square root of 63 divided by 7, which is equal to the square root of 9, and the simplest form of the square root of 9 is 3. For the second example, we have the square root of 6 divided by the square root of 5. Since our denominator is an irrational number, we will rationalize the denominator by multiplying the numerator and denominator by the smallest factor that results to a perfect square radical in the denominator. We will multiply the numerator and denominator by 5 to remove the radical in the denominator. So to simplify it, we will have the square root of 30 divided by 25, or that is equal to the square root of 30 divided by 5. For the third example, we have then the square root of 16a cubed b squared divided by 2, the square root of 2ab. We can now divide what can be divided. So we will have 5 the square root of 8a squared b. Since 10 divided by 2 is 5, 16 divided by 2 is 8, a cubed divided by 8 is a squared, a cubed or 8 squared divided by b is also b. And then simplify, we will have 5 squared of 4 multiplied by 2 multiplied by 8 squared multiplied by b, which is also equal to 5 multiplied by 2 multiplied by 8, the square root of 2 multiplied by b, since the square root of 4 is 2 and this a squared or the square root of 8 squared is 8. So the final answer will be 10a square root of 2. Let's proceed to multiplication and division of radicals of different index. To multiply and divide radicals having different index, we have steps to follow. First step, to multiply or divide radicals of different indices, change them all to the same index. Step number 2, express radicals with fractional exponents. Step 3, change the fractional exponents to equivalent fractions with the same denominators. Step 4, rewrite the equivalent fractional exponent in radical form. And step 5, perform the indicated operations. Let's have an example. For the first example, we have cube root of 5 multiplied by square root of 6. As you can see, we have different index and also we have different radicals. So what we're going to do first is to convert them into expressions with rational exponents. So we will have 5 raised to 1/3 multiplied by 6 raised to 1/2. Then change the rational exponents to similar fractions. We'll get 5 raised to 2 over 6 multiplied by 6 raised to 3 over 6. Rewrite the equivalent fractional exponent in radical form. We will have 6th root of 5 squared multiplied by 6th root of 6 cubed. Simplify, we will get 6th root of 25 multiplied by 6th root of 216. Lastly, to get the product of the expressions, we will have 6th root of 5,400, which is our final answer. For the second example, just like what we did in the first example, to divide radicals with different indices, first convert them into expressions with rational exponents. So to convert cube root of 4 divided by 6th root of 2, we will have 4 raised to 1/3 divided by 2 raised to 1/6. Then change the rational exponents to similar fractions, which is 4 raised to 2 over 6 divided by 2 raised to 1 over 6. Rewrite the equivalent fractional exponent in radical form. We will have 6th root of 4 squared divided by 6th root of 2. To simplify, we will get 6th root of 16 divided by 6th root of 2, which is equal to 6th root of 8. Since 6th root of 8 is not yet in its simplest form, we will transform 8 into 2 cubed, so we will have 6th root of 2 cubed. Transform the expression into a rational exponent, we will have 2 raised to 3 over 6. Get the lowest term of the exponent, which is 1/2. Lastly, convert the resulting quotient of the expressions into radical form, so we will have the square root of 2. That is our final answer. Did you also have the same answer? Good job! We are done with our lesson for today. I hope you have learned a lot. Thank you so much for your learners. Until our next lesson,